Okay, so solutions and solubility, loosely defined, solution is a homogeneous mixture, okay, of several, two or more things that makes the mixture. Homogeneous means you're going to be uniform throughout, right? So remember that from chapter 1. And specifically, they say you've got a particle size smaller than 2 nanometers. There's this size difference because sometimes you can have suspensions of large particles that don't fall out of solutions, but they still stay suspended in there. And that size has to do with light scattering. So if you've got a particle size bigger than 2 nanometers, then your solution will look cloudy or translucent. And if it's much bigger, then it's going to look solid. So for instance, milk, because it's solid, then you know it has particles that are larger than 2 nanometers, which is probably the fats and the proteins. Whereas the apple juice you see on the store shelf must have particles smaller than 2 nanometers because it's a clear liquid, if that makes sense. I'm not going to test you on that, but that's on that particle size limit. That's kind of what you're looking at. We've got, in our mixture, we usually have two things. We have the solvent and the solute, and you need to know the definitions of these: the solution, the solvent, and the solute, okay? The solvent is, generally speaking, the liquid that other things dissolve into. And I say generally speaking because you can have homogeneous mixtures that don't have a liquid as a base. Like air is a homogeneous mixture. We can look at it as a solution of gases. Or brass is a homogeneous mixture. We can look at it as a solution of more than one metal solid. But for the purposes of chapters 9 and 10, we're going to be talking about liquid solutions. And so for those solutions, our solvent is the liquid that other things are dissolved into. And then the solute, so liquid that the solute is dissolved in. And then the solute could be liquid, solid, or gas that is dissolving in the solvent. Okay. So for instance, if I have a solution of salt water, what is my solute and what is my solvent? Perfect. If I've got salt water, Trisha says that water is a solvent and salt is the solute. Perfect. Okay, what if I have a solution of 30% isopropyl alcohol in the store? 30% isopropyl alcohol is telling you that 30% is isopropyl alcohol and the other remaining 70% is water. So which of those is the solvent and which of those is the solute? Perfect. Sarai says alcohol is the solute and water is the solvent. Okay, what if you got a solution of 70% alcohol from the store, which means you'd have 70% alcohol and 30% water? Which would be the solute and which would be the solvent? Trisha's exactly right. Tracy's exactly right. It would be opposite because of the concentrations. If I have 70% IPA, then I've got more isopropyl alcohol than water, then it would be more appropriate to say that I've got water dissolved in my isopropyl alcohol than it would be to say that I've got isopropyl alcohol dissolved in my water. Now, this obviously, it's murky. What if I had 50-50? Which one would be the solute? Which one would be the solvent? It doesn't really matter, all right, at that point, because you've got about the same as each. But I want you to, generally speaking, if you recognize that something's present in a much lower concentration, then that would be the solute. guys with me? Feeling good about that? Okay. So what about, say, if I was doing this in a mixture of gases, so we weren't looking necessarily at just liquids, but if we said something like air, which is 80% nitrogen and 20% oxygen, what would you say is the solute? Which one's the solvent? Perfect. Trisha says N2 is going to be the solvent and O2 is going to be the solute because there's more nitrogen than oxygen. So we could say the oxygen's dissolved in the nitrogen. Okay, good. So the next question I have to ask you guys about solutions is, why do solutions occur? Why does salt dissolve in water? Why do isopropyl alcohol and water dissolve in each other? Close. I want you to think back to chapter 8, this first lecture we had on lecture 8.4 that we did in Canvas. Why do things dissolve in each other? So for instance, why does salt dissolve in water? We covered this in chapter 4. We covered this in chapter 8. Sarah's exactly right. Sodium and chlorine have charges. Water is a polar molecule, and it has partial charges. And those charges interact favorably with one another. Do you guys remember this from chapter 8? From just a week ago? And we said certain types of molecules would be soluble and certain types would not based on their intermolecular forces. Okay, that is what your first section here is about. Which is more likely to form a solution with water. Okay, so this is what kind of intermolecular forces is water going to be feeling? And what kind of intermolecular forces is CH18 going to be feeling? If you can't answer that question after a little bit of reflection, look at lecture chapter 8.4 again. Okay, these are covalent molecules. So the H and the O are held together with covalent bonds, but one water molecule and another water molecule are held together with hydrogen bonding, or the polar dipole-dipole interactions that are especially high if your H is bonded to your O. And then your CH18 then, individual CH18 molecules, two different CH18 molecules, are held together with what kind of intermolecular forces? Perfect, London dispersion. Okay, so the key to this section is to say, remember, if something is soluble in water, it has to be either polar or ionic. Okay? Hydrogen bonding dipole, dipole, ion, ion. These are the things that it has to be subject to. For CH18, since it's subject to London dispersion forces, yours have to be subject to London dispersion forces. And then these, I've got some metals in here that are just kind of tricky questions. You can ignore those. I want you to answer the rest of these though. Okay? So come to class on Wednesday with your chapter 9 in class activity sheet and your chapter 8.2 in class activity sheet, and we'll go over all of these, and then we'll probably finish lecturing on chapter 9 enough to get you through this first sheet, and then we'll review that and do 9.2 on next Monday, okay? And I will see you in a couple days.